In this video, we're going to have a look at what's called the normal distribution. So the graph of a normal distribution is the bell-shaped curve, which is smooth and symmetrical about its mean. A lot of things that occur in real life are normally distributed if we have a look at a large enough sample. Some examples of this would be if we looked at people's heights or grades in a test, or even if you think about the time it takes popcorn to pop in a microwave. So we want to have a little bit of a closer look at how our scores are distributed under that normal curve. So if we look at our whole curve, there has to be 100% of our scores underneath that curve, and our mean's here in the middle, remember. But we want to break that down a little bit further. So if we have a look, if we move from our mean, we go up 1 standard deviation, and from our mean we go down 1 standard deviation. So we've moved 1 standard deviation either way. That section in the middle of our normal distribution is going to contain 68% of our scores. If we move a little bit further out, so if from the mean we go up 2 standard deviations this time, and go down 2 standard deviations, so we're within 2 standard deviations either way, that section of our curve under the normal distribution will contain 95% of our scores. And if we go one further, so 3 standard deviations either way from the mean, then under that section, within those boundaries, is going to contain 99.7% of our scores. So within 3 standard deviations of our mean, that's almost all of our scores. So those little end bits there, that's the last 0.3% to make up that 100% of our scores. Another way that we can look at this distribution is if we draw them all in the same one. So this is our mean here. If we go 1 standard deviation either direction, then we've got 68% of our scores within those boundaries. If we go 2 standard deviations either direction of the mean, we'll end up with 95% of our scores in that region. And if we go 3 standard deviations either direction, then we're going to end up with 99.7% of our scores in there. The other important thing is if we look straight down at where our mean is, because it's normally distributed, that means that 50% of our scores are going to be above that mean, and 50% are going to be below the mean. So it's all completely symmetrical. I want to have a look at a few examples. So the first example is this situation. The marks on a test are normally distributed with a mean of 72 and a standard deviation of 6. The first part of the question asks us what mark is 1 standard deviation above the mean and what mark is 1 standard deviation below the mean. So for the first part of that, this 1 standard deviation above the mean, if our mean's 72 and our standard deviation is 6, then 1 standard deviation above would be 72 plus 6, which would be 78. 1 standard deviation below the mean would be 72 minus 6, which would be 66. The next part of the question asks us what percentage of students got a mark between 66 and 78. So they're the numbers that we just found in the first part of the question. So we know that 66 is 1 standard deviation below the mean, and 78 is 1 standard deviation above the mean. And from our curve that we wrote down on the previous slide, we know that 68% of the scores lie within 1 standard deviation of the mean. So there's 68% of students who got a mark between 66 and 78. The last part of this question asks us what percentage of students scored between 54 and 90. The way I like to do these questions is to draw a little sketch. So we'll draw our normal curve, and then we're going to draw in, we know our mean is 72, and we need to find whereabouts these numbers, 54 and 90, lie in relation to the mean. So we're going to count up our standard deviations. So 1 standard deviation above we know is 72 plus 6, which would give us 78. 2 standard deviations above would be plus another 6, which would take us up to 84. And 3 standard deviations above that mean, we'd add 6 again, and we'd end up with 90, which is the higher number that we were looking for. So we know that 90 is 3 standard deviations above the mean. Now we need to go the other way to get to 54. So we'll go 1 standard deviation below was 66. 2 standard deviations below, we'd subtract 6 again, and we'd end up at 60. And 1 more, and we'd end up at 54. So we've got 54 is 3 standard deviations below the mean, and 90 is 3 standard deviations above. And we know, again, from that picture we looked at earlier, that 99.7% of our scores lie within those 3 standard deviations of the mean. So our answer is 99.7% of students scored between 54 and 90. Our second example says the heights of a large group of adults are normally distributed with a mean of 170 centimetres and a standard deviation of 8 centimetres. What percentage of people in the group are taller than 162 centimetres? So again, the first thing I like to do for these is draw a diagram. So if we draw our normal curve, we've got our mean of 170 centimetres. We need to figure out where this 162 lies in relation to our mean. We know our standard deviation is 8, so because this 162 is 8 below that, then that 162 is 1 standard deviation below the mean. Okay. So we know that above that mean, the rest of this whole section contains 50% of our scores. But we need to add on this little extra bit. So what we know from right at that first diagram that we did was if we went 1 standard deviation either side of our mean, then that section in there would contain 68% of our scores. So because it's symmetrical, this section here, just from the mean to 1 standard deviation below, is going to contain half of that 68. So this section here is going to contain 34%. So the answer to our question, which was what percentage of the people in the group are taller than 162, so we wanted the percentage going all the way from here, all the way up to the rest of them, anyone that's above there, would be that 50%, which were above the mean, as well as that 34% there. So the answer to that question would be 34 plus 50, which is 84%.